In this video, we're going to go over adding and subtracting rational expressions. So as a warm-up, in the last unit 2.2, we went through multiplying and dividing rational expressions. So we're just going to have a short question to go through an example of that. So in this case, we have a division. So one of the things we have to do when we go through this is we need to factor so that we could reduce. So on the side, I'm just going to factor out, so I factor n squared minus 7n plus 12. So here the product is going to be 12. The sum is minus 7. And so the integer is going to be minus 4 and minus 3. So this is going to factor to n minus 4 and minus 3. So again, because the a value is just 1, we could just use the integers. N squared minus n minus 6. I'm just going to do this quickly. The product is negative 6, so the integers are going to be negative 3 and positive 2. And then lastly, the difference of squares of n squared minus 4, that's going to factor to n minus 2 and n plus 2. So let's rewrite the equation now that everything is factored. So we will just do it down here. This is equal to 2 times n minus 4 times n minus 3 divided by n minus n minus 2, so n minus 3 times n plus 2. And since I'm dividing by a fraction, I'm just going to multiply by the reciprocal, so I'll just make that next step as well, as well as rewriting my expressions in factor form. So it's going to be over 5n minus 4. So remember, it's just going to do off on the side the restrictions. We need to look in 3 places in terms of restrictions when we're dividing. So the denominator of our dividend, and then also both the numerator and the denominator of the divisor. Once we flip it, it really doesn't matter. We just know we have to look at both places. So in this case, n can't be 3, n can't be negative 2. We already have a 2. No, we already have a negative 2, but we don't have a 2, so n can't be 2. And finally, n can't be 4. So those are the restrictions of that question right away. And then let's just go off to reduce. So here could naturally sort of extend that and go off and reduce. So n plus 2 and n plus 2 reduce over there. N minus 3, n minus 3 reduce over here. And wow, n minus 4, n minus 4. So a lot of reductions happening over here. So this is going to be really simplified to be 2 times n minus 2 all over 5, where n can't be. So again, we're going to say over here 3, negative 2, 2, and 4. All right, so that's a review of division. So the success criteria will be that you will be able to add and subtract 2 rational expressions with a simplified result. In other words, it can no longer reduce, but reduce as far as it can. And then finally, state the restrictions on the variable. So on this example, let's start off with a numerical example. So we have 5, 6 plus 8, 21. So how will we do this normally is that we need to find a common denominator. So we could always find a common denominator of 2 fractions by multiplying 6 and 21. So this is going to be really important later on, especially once we get to trigonometry and proofs, is that we think that, well, 2 fractions, we can't add them together because there's no way the denominators look so weird. There's no way they would come with a common denominator. Well, that's untrue, because you could always come up with a common denominator by just simply multiplying the 2 denominators together. So we could do that in this case by multiplying 6 and 21, and we get 126. The issue there is that it's not a huge problem, but the issue is that that's not the lowest common multiple. So if we don't come up with the lowest common multiple for the common denominator, we realize our answer, our fraction, is not going to be fully simplified. In other words, we're going to have to further reduce with that. So idea, if we would choose the lowest common multiple as the common denominator, the likelihood of us having to do that is going to be less, or at least we're not going to have to reduce as much. So let's do this in 2 ways. Traditionally, we say, well, what's the lowest common multiple of 6 and 21? If you're really good with their numbers, you may say, well, it's going to be 42. So we could convert each of those fractions to be 42. So 5 over 6 to something over 42. Well, we need to multiply the top by 7, because that's 6 times 7 is 32. So 42. So 7 times 5 is going to be 35. And likewise, you do the other fractions, 42. So 8 over 21 times 4 is equal to, well, 21 times 2 is 42. So if they multiply 2 to 8, that's going to be 16. So that's going to be 35 plus 16 is going to be 51 over 42. And unfortunately, in this case, even though we chose the lowest common multiple, 51 over 42 can be reduced further. We divide top and bottom by 3. So we get 17 over 14. So that is the final reduced answer to that. But I just want to show you another approach that we could take if our numeracy wasn't so strong. We couldn't exactly see that 42 was the lowest common denominator. But also going through this example will sort of highlight some of the steps that is really key to once we get to rational expressions, and we may not be able to see easily the lowest common multiple or lowest common denominator, that these were the steps that we would take. So our question again, let me rewrite it, is 5 over 6 plus 8 over 21. So one of the things that we could do is just break down our denominator into the prime factors. So in this case, 6 breaks down to 2 times 3, and then 21 breaks down to 7 times 3. Now our next step is really determining what the lowest common denominator is. In the process, the step that we could take is just choose one of the denominators. Doesn't matter any one. I always like to choose the left because it's work left and right. So there's 2 times 3. So the lowest common denominator starts off with 2 times 3. Then we start looking at the factors of the other denominator. And we look, well, is it already in the lowest common denominator that we're kind of calculating for? In this case, we have a 7. Well, is 7 already in 2 times 3? Nope. So we're going to include 7 now. That's part of our lowest common denominator. So multiply by 7. And then likewise, next thing is look at the 3. Is 3 already there? Oh, it's already there. So we're not going to include it this time. So now we have to figure out what the numerator is. So in our first fraction over here, 5 over 6, well, we have to come up or convert this fraction to have a denominator of 2 times 3 times 7. So we need to take 5 and multiply it by something. But what we multiply by, well, if we look at, it's already originally 2 times 3, so we had 2 and 3 in the denominator, we multiply by 7 in the denominator, so we have to multiply by 7 in the numerator as well. We look at our other fraction, well, originally we had 7 times 3, and now we have a common denominator of 2 times 3 times 7, so there's already 3 in the 7, so here in this case we have to multiply 8 by 2. Notice that this process was very similar to what we did up here, except we just sort of did the mental math. But here we broke it down by steps, and now we get the same as we did before. This is going to be 35 over 42, because 2 times 3 is 6, times 7 is 42, and then 8 times 2 is 16 over 42, which is going to give us 51 over 42. Again, we want to simplify that to 17 over 14. So eventually we do get the same answer, but here's a little bit more rigid approach to it, or a process to getting that lowest common multiple. So here would be another example where we want to simplify and state the restrictions. So then we want to add and subtract all this together. So this one is a little bit tricky in terms of figuring out what the lowest common multiple or denominator is of 8x squared, 4x, and 6x cubed. So in order to do this, we sort of need to break it up into 2 parts. So just let me start writing this out. And here, just we're off to the side, we have 8x squared, 4x, and 6x cubed. In order to get the lowest common multiple, we need to break it up into 2 parts. First, we need to look at our coefficients, 8, 4, and 6. And we need to figure out what the lowest common multiple of 8, 4, and 6 is. Well, this one isn't going to turn out too bad because 4 is a factor of 8. So we just really look at the lowest common multiple of 8 and 6, and we're going to discover that's going to be 24. Then we need to go look at each of our variables. In this case, we only have 1, but if there are more than 1 variables, then we have to look at each of our variables. And, well, we know the variable has to be in there, but what's the exponent? And the trick is, we're not doing anything more than just choosing the highest exponent that we have. So in this case, it's a 3, it's a cube. So our lowest common multiple is 24x cubed. And now we just have to convert each of our fractions to an equivalent fraction where the denominator is 24x cubed. So here we have to go 8x squared. So what do we need to multiply 8x squared to get 24x cubed? So the way we look at it is we could divide 8x squared into 24x cubed. So 8 into 24 is going to be 3. So we're going to multiply by 3. And then x squared into x cubed, we're left with an x. So basically we have to multiply the numerator by 3x. Because we multiply the denominator by 3x, we get 24x cubed. So the next one is we have a 1. So I just write this out, but we just recognize that whatever we're going to multiply, that's going to be. So here, that's 4 into 24 is going to be 6, and then x into x cubed is going to be x squared. So they'll multiply the numerator there by 6x squared. And finally, the last term that we have is 5 over 6x cubed. So where we have an x cubed, so really we need to multiply the numerator by 4. So finally, we're going to get 9x over 24x cubed minus 6x squared minus 24x cubed minus 20 over 24x cubed. And here we don't want to leave that as our final answer because the reason why we chose the common denominator is so that eventually we have a polynomial up top. So we get 9x minus 6x squared minus 20 all over 24x cubed. In reality, I could really just skip this step, so to speak, and just wrote everything over 24x cubed because I know that's going to be the common denominator for that. Okay, so now we're going on to the next example where things are a little bit more tricky, only because now we have a polynomial on top. There's a numerator. In this case, it's a binomial. But our process is still very similar. In fact, the process is still identical. So we have to figure out what the lowest common denominator for 6 and 21 is. So in this case, we already had that example. It's going to be 42. That's why I chose the example that I did up top. So here, we have to convert each of these. I'll just write what I did before. Is that I recognize I have to multiply, the lowest common multiple is going to be 42. So I have to multiply by 7 for that fraction and multiply by 2. So we're really doing likewise with our numerator. Recognizing that here we have x minus 4, but we need to multiply that by 7. Because I have to multiply by 7 to get a lowest common multiple. And likewise for the other fraction, I have to multiply by 2. So this is going to be 2 times 2x minus 1. So now we go off and expand and simplify this. So here I'll just keep this 2 separate fractions for now. Sorry, I just miswrote this. Not be x minus 7. It should be x minus 4. So this is going to be 7x minus 28 all over 42 plus 4x minus 2 all over 42. So now that I have a common denominator of 42, I'll just convert to a single fraction now and do the other combining the polynomials, so simplifying the polynomial up top in my head. So 7x plus 4x is going to be 11x, and negative 28 plus a negative 2 is going to be a minus 30. So there's a final answer. We can't reduce that any further. We could try, but the numerator is not even factorable. Okay? So in this case, do we have any restrictions? So we make sure we have to answer the question. State the restrictions. Well, in this case, there's no restrictions because we have no variable in our denominator. All right? So there's an example where we have adding two rational expressions, except the denominators of both rational expressions is just integers, but we have a polynomial up top. Next one is, again, a little tricky, because now we have a polynomial on the denominator, in this case, two binomials. So how is it that we go off and add these? So as I said earlier in the video, we'll always be able to add two fractions together, even though you might think, oh my gosh, what's the lowest common multiple of these two denominators? And like I said, we could always get we could always get a common denominator by multiplying our denominators together. In this case, it will also be the lowest common denominator because they're not factorable. So we can't break them down to any prime factors. So we just multiply them together. So here, I'm going to break this up into 2, just so you can see what's going on. So here, our lowest common denominator is going to be 2x plus 1 times x minus 3. 2x plus 1 times x minus 3. Let me rewrite that. That's ugly. 2x plus 1 times x minus 3. And then, again, we just have to convert each of our fractions to the equivalent fraction of that with that denominator. So in this case, 3x, I need to multiply to x minus 3 because that was the binomial that was missing. And for the other fraction, it's going to be 4 times because we're going to have x minus 3 in the denominator. So we have to multiply by 2x plus 1. And again, we just have to expand and simplify. So in this case, I'm going to just write this all over one fraction for now. And so we quickly expand. We get 3x squared minus 9x. And the other polynomial we expanded is going to be plus 8x plus 4. And then just have to combine our like terms in our numerator. So we get 3x squared, negative 9x plus 8x is going to be negative x plus 4 all over 2x plus 1 times x minus 3. So again, we do not have to expand. Simplifying does not mean expanding. In this case, this is simplified. The question is, can we reduce this any further? So here we get 3x squared. Can the numerator be factored? So what two numbers multiply to 12 and add to negative 1? It looks like it might be 3 and 4, but be careful. It's not a product of negative 12, it's a product of 12. So this one cannot be factorable, so therefore that's our final answer. We have to look at restrictions. So as I said above, actually getting the restrictions for adding subtracting is really straightforward. We just look at the denominators of both of our fractions. So in this case, let's do a quick check or quick algebra over here. 2x plus 1. In this case, we don't want that to be 0. And so 2x can't be negative 1. So divide both sides by 2. X can't be negative a half. So in this case, x can't be negative a half. And the other one, x can't be 3. So there's the restrictions on that question. Finally, we get a question that looks a lot harder. Looks really difficult. But this is where we sort of go back to the original example that I gave with the numbers, and this is the steps that we can do. Okay, and really this is the culmination of what we want from topic 9. But really, when adding and subtracting, this is going to be the hardest type of question that you will get. So if you can get this one, that's fantastic. So this one looks really hard because you're thinking, well, there is no common denominator. Well, there is. We're going to take the two and multiply together. But it's going to look really ugly. So remember at the very beginning of this unit, I said, well, one of the things that we really want to do all the time if we can is factor. So in this case, we want to factor our expressions over here, and hopefully something comes up that we can notice. So here I'm just going to go off to the side. Well, 2x can't be factored anymore. X plus 2 can't be factored anymore. But what about x squared minus 1? Well, recognize this is a difference of squares. So it's going to be x plus 1 times x minus 1. The other one is x squared plus 3x minus 4. Well, what two numbers multiply to negative 4 and add to 3? Well, because my coefficient here again is 1, this just breaks down to my integers. And we could do this one in our heads. So in this case, it's going to be x plus 4. My two integers are 4 and negative 1. That's what added to 3. So let's rewrite our question now in factored form. So 2x over x plus 1, x minus 1, minus x plus 2 all over x plus 4 and x minus 1. Okay? So that's actually huge because what we could recognize, and it's going to save us a lot of time now, is that there is a common factor in the denominator. So this is going to save us a bit of time. So now we go through the same steps of figure out what a the lowest common denominator is in this case. So here I'm going to write out it's two big fractions. So again, we're going to start off with denominator of 1. So I'll start with the left. So there's going to be x plus 1 and x minus 1. Now we have to look at the factors of the other denominator. Well, is there an x plus 4 already in my lowest common denominator? Nope. So we're going to add that. And then finally, do we have already x minus 1? We do, so we don't want to include that one again. And there's our lowest common denominator. Looks weird because it's a polynomial expression, but that is our lowest common denominator. And we do not need to expand that. You do not want to expand that. Do not waste your time expanding that. That is simplified already. Now we have to convert our other our fractions to the equivalent. So in this case, the left fraction, we already have 2x. What is it that I need to multiply to this fraction to get that lowest common denominator? Well, I already had an x plus 1 and x minus 1, so I really need to multiply by x plus 4. And the other fraction, I already have an x plus 4 and an x minus 1, so I have to multiply by an x plus 1. Now I'm going to save myself a lot of work and work everything over my lowest common denominator, which is x plus 1, x minus 1, x plus 4. So now I'm going to expand the numerators in two separate steps. So here 2x times x is a 2x squared. 2x times 4 is a positive 8x. Now we need to really take care of this when we subtract. Okay, when we subtract. Because really we're subtracting this entire thing. Alright? So what we're going to do is do a bracket and, do a minus, and then we're going to bracket everything that we're going to expand here. Okay, because we're really subtracting that entire quantity. So let's do this in our heads. X times x is x squared. X times 1x is going to be x plus a 2x is going to be giving me a positive 3x. And then 2 times 1 is going to be positive 2. So we're subtracting that entire quantity. Okay, that's one of the big common mistakes I see when we do a subtraction is people not subtracting the entire quantity, but they're just subtracting the x squared. Okay, so maybe my very next step is I'm going to expand that, distribute that negative. So that could be a negative x squared minus 3x minus 2. So I'm not going to make any silly mistakes. My common denominator stays the same. And then I have to simplify the last step is going to be 2x squared, or 8x, 2x squared minus an x squared, so an x squared, I didn't see the x squared there, a negative x squared, so the x squared, 8x minus 3x is going to be a positive 5x minus 2, all over x plus 1, x minus 1, x plus 4. Okay, and because we already have this factor, so that's an advantage of having this factored. Stating restrictions is straightforward in this case then, so the x can't be negative 1, it can't be 1, it can't be negative 4. Because if it equals either one of those, it'll make our denominator 0. Okay, so that's how we do a question like that. So a little bit of work, but I will argue that we sort of understand the process. Then it's just relying on our previous skills of working with polynomials, in this case, multiplying, expanding, and then combining the like terms.